Okay, so well, look. Do you guys even know what an algebraic identity is? Okay. Let's just. If you factor that, what do we get? Okay. This is called an algebraic identity. You guys would probably just call that an equation. Yeah? So this is a different way of saying it's an equation. Okay, but the book kind of defines it as an equality, true for all x, or all theta, or whatever. Whatever you plug in there, it works. If there's something you plug in and it doesn't work, it's not an identity. Okay. So let me give you an example of that, I guess. Okay, so that's not an identity. The question is, how do you show that? Okay, so one way they might state it is prove that sine x tan x equals cosine x is not an identity using the counterexample. This is a pretty useful tool in math. Sometimes we're just going to basically plug and chug. So we're going to try values. If they work, great. If they don't, we know that we have our counterexample. Because some of them will work. Okay. What if x equals 0? So that means I have sine of 0. Oop, not theta. In a habit there. Okay, the question is that true? Sine at 0 is 0. Tangent 0 is it's not 1. I think it's 0. And cosine 0 is 1. Does 0 equal 1? Ah, so that is not true. This is our counterexample. Okay. So first guess, we found 1. So we've shown that that doesn't work for all x values. That's the idea behind it. Can you read it? Let's have a techno rave next door. Since we've been working in radians a lot, will want to try to stay in radians. But besides 0, you might try pi over 6, pi over 4, and pi over 3. Okay, those are the more common ones, and the values are listed in the tables in your books, so you can just look them up. They're getting her done next door. Jansen just doesn't like you. So if this actually produces a true answer, you have to go try others. Okay. So basically you're guessing and checking. Then you keep going. Because if it tells you says prove it's not an identity, you just got to try others. Yeah. You might also try pi, of course, or pi over 2, because that's 90. Those should cover it. But yeah. They had a little bit of fun. Starting right over. Okay, are we good there? Okay. I heard one, yeah. So I'm going to go with it. Okay. The others, we're going to write down a whole page of true identities that are true for all theta values. Okay. Yeah, sine theta is 1 over cosecant. Whoops, that's not what I wanted to write. You throw off my groove. Cosine and secant go together. We know those are all true for all values of theta. You can plug anything into it, it works. Okay. We can also put these up there, the ones from the warm-up. Mm-hmm. So those are our basic 6 trig identities. All right, we're going to add 5 more to it. Okay, this is based kind of like, should be pretty easy to absorb because it's prior knowledge. I'll show you how to use them in a bit. Okay. We can also write tan and cotan in terms of sine and cosine. So tangent is sine over cosine. What do you think cotangent is? Cosine. Yeah, you just the reciprocal. Okay. So we'll use this one a lot. Tangent, that's pretty key. It gives us a way to solve some things pretty easily. Okay. All right, where are we going to use those? Here's one way we can use it. Something you probably could have done already. Yeah. Okay. Easy route. They're reciprocals. Right. That's, I mean, if you know that, great. There's your answer. Okay. I'm going to show you kind of the way to build it up with the identity, just to give your mind some time to start absorbing these things, because we're going to get pretty heavy into it. Secant theta is 1 over cosine theta, right? That means that secant theta is 1 over 3/4. This cosine's 3/4, which means that is true. And so if you wanted to write more of a formal answer, that's what we would see. The one on the left is perfectly acceptable as well. Okay. Questions so far? We're doing okay. All right. 3 more identities. We'll use these quite a bit. They're called the Pythagorean identities. So they're very similar to the Pythagorean theorem. The most used one, sine squared plus cosine squared equals 1. The next one's tangent squared theta plus 1 equals secant squared theta.
Oh my God.
I know. Oh, you know, we sit at the table and we stare at things for hours at a time. And then just, there it goes. Great idea. Bam. There's the last one. I read an article yesterday that the teenager misery index is at an all-time high. Is that true?
Probably. Yeah.
Are you guys miserable?
Yeah.
Good. I'm right there with you guys. I'm tired all the time too. This morning, 3:30. Yeah, it was awesome. Yeah, I wish I could oversleep. Okay, we're going to have to use these just like the last problem. So let's, if cosine theta is 3 over 5, find cosecant. So we have to find a way now to connect those two, because cosecant and cosine are not connected by an identity. Yeah, that's exactly what it is. We're mean and evil. Thank you. Is there a way for us to connect those? cosecant is 1 over sine, right? Could we use that to generate? We can use that to generate sine, right? And then we can just do the reciprocal to find cosecant, right? So we're going to start with that right there. So plug cosine in, that's 3/5. Oop, don't write cosine. Yeah, but it. All right. Just FYI, if I write cosine squared theta, that's the same thing as cosine theta squared. Yeah. So 3/5 squared right there. It's just prettier when you write it like we write it. Yeah, I am actually. It's elegant, beautiful. All terms used to describe mathematics at its finest. Ew, that's not how I would say it. Yeah, so square it first. 9/25, and then subtract it. What's 1 minus 9/25?
16.
Yeah, 16/25. Anybody not get that? This right here is 25 over 25, right? Minus 9 over 25. So we end up with 16 over 25 here. Very. I wasn't. And then square root it, right? Well, it's sine squared, so close. Positive or negative? Remember, when you square root a squared number, you have to include the negative case because it could be a negative in there. So what's cosecant? Yay! Yes. Gosh. The peanut gallery showed up today. It's not Mystery Science Theater 3000. Thank you. I know, right?
Why do you have a mouse right there? You know, like a mouse key for a computer? Computer theta.
Because I try to mix things up a little bit, you know. Next time it'll be a cat. Okay. Are you clear on the process that we use there?
Just make sure that Mikey's not driving at the time.
What? I mean,
Do you kill cats with your car?
you do it all the time.
Jerk. It's unnecessary.
If they run in front of me, I'm not gonna stop. He speeds up though. I speed up though. It's like 20 points if he can get it in the middle of the body. 20 points.
What do these points get you? Nothing.
He says 20 points, right? Yeah.
Do that with your girlfriend in the car and let me know how it works out for you.
God, I already get yelled at.
Do you have any questions?
Yeah, we know that.
That's part of it. Okay, let's do Friday. Today, so I haven't shown you everything, right? So today you might just focus on those problems. The rest of it I'll show you tomorrow. 7 and 8 are doable. 9, 10, and 11 are actually doable if you really want to. It doesn't matter though. And then all the reviews, of course. And I want you to note the review problems are going to start being at least half your responsibility score. Okay. Yeah. I'm going to put a little more emphasis on everybody doing the review problems this semester. Okay. So you can start on that. Get it done tonight. Maybe you have questions tomorrow. Good time to ask.